Yum, yum!
Greg here from Pixel Fondue. Happy Friday. So this video is going to cover a series of nodes called probe nodes. Now, I think these are really underutilized. I'm going to try and show some what I think are really practical uses for them. And a lot of 3D work, if you've done a lot of production work, I think you'll agree 3D is often just a big exercise in problem solving. So trying to figure out solutions to problems or desires from clients or whatever. And probe nodes are just another tool in the toolbox to solve problems. One of the most interesting probes in the Emmy kit from Steve Hill is the UV texture probe, and that will return a color value on a UV map, depending on the location of the locator. You can also use a more complicated setup to color replicas that are scattered across a surface based on the UV texture color that they're scattered on. So if you have a spaceship and you scatter a bunch of greebles on it and the spaceship is textured with the UV map, those greebles will take on the color of the pixel underneath it with this probe. So that's super useful. Let's start a little bit more simply, then we'll get a little more complicated here. So initially, to set this up, we're just going to use a locator to sample the color underneath it here in this plane, and we're going to drive the color of this torus with it. So I'm just going to pop open a schematic here. Whoops, not modeling tools, schematic. And then I'm going to drag my locator in. I'm going to drag in my triangulated mesh. And again, this needs the mesh to be triangulated to get the proper UV value. Now, if you don't want the mesh triangulated, sort of like the map probe, you can merge it into an empty mesh and add a triangulation mesh op and just hide it and use that to get the triangulated info. And it'll just follow along your animation with your regular mesh all you want. So you can subdue that and still get the UV info from the triangulated one. But we're just going to triangulate this one. We don't, this is a triangulated mesh here. We don't need it to be quad, so we're good. And then I'm going to take my constant color here for my torus. I'm just going to drag in that color node there, right? So, and then I'm going to add a UV texture probe. And again, this is with the Emmy kit from Steve Hill. And then let me just connect this guy up. So the locator is going to have some position channels, and so we'll just drag those in. We're going to hook that up to position. And then our triangulated mesh is going to be our plane. Now the UV texture we've got to feed in as well, and that is our custom UV here. So we'll just drag this out, and we'll plug that in with our graph connection. Remember, the purple graph connections are sort of bundles of channels. They're sort of like a whole bunch of information in one connection, whereas these white ones are just like a single channel, like one value going in, right? So just in case you forgot that or don't know the difference between the purple ones and the white ones. And okay, so now we're going to be able to use our locator here, and as we move it around, we're going to be able to get some values. So let me just actually parent my torus to the locator here, so when I move it around, you can see them both moving at once. So if I'm over orange and I look at the UV texture probe and I look at the channels, I should be getting that orange RGB there, right? And then I can just pipe that color into the color of my constant like that. And now when I move my locator around, I'm going to pick up those colors, and it's going, the probe is, and it's going to feed them into my torus. So that's cool. That's a neat trick. You can, sample UV texture colors anywhere on a mesh with a locator, and then do whatever you want with it. In this case, we're driving the color of this torus. But let's say we want to do something a little more useful. And let me just hide my torus here, hide my locator. I'm going to turn on my replicator. So here I've got a bunch of spheres replicated to, I'll just lower those down a little bit, replicated to points on the surface, right? So if I look at my replicator over here, I've got a plane going in and a prototype here, right? So the plane is providing the points, just the vertices of the plane, and the sphere is being replicated to all of those. We've seen this before with replicators, but how do we get the UV color from each point on this plane attached to that particular replica? That's what we really want. That's the cool thing about this probe. And I have to thank Chemo for this, who came up with a really cool schematic. I never would have figured it out on my own. To do this, Steve Steve may have figured out an even simpler way to do this. Eventually, I'd like just a checkbox or something somewhere, so people don't have to like go through this whole thing. But let's you can also make an assembly, so maybe I'll do that as well to like help you out. You can save the assembly and bring it back in, so you don't have to remake these schematics. But okay, let's go through this because it's a little bit complicated. So I'm going to unplug my locator here and just sort of move it to the side. I've got my UV texture probe, and it's already hooked up to my triangulated mesh and my color map there. I don't want it hooked up to the constant anymore. That's going to be gone, so we'll just move that to the side. So we've got, a UV texture probe, and we've got the mesh in there, and we've got the plane going in. And on the other side, we've got this replicator, right, going over here. So we need to be able to feed the values of each one of these points on this plane, those positions, into an array, and then we need to match up those positional arrays with a color, another array of colors from this UV texture probe. So we need a couple of arrays here, and we need to sort of merge them back together at the end. So this is what we're going to do. We're going to add a particle array at this end. Whoops, can I type? Particle array. Particles to array, right? And so this will work with any particle system or vertices. In this case, we're just using vertices, but I'll show it with the particle system later. So here's our particles to array. So our plane, we're going to plug in here as the particle source. And what that's going to do is it's going to put all of these positions. I can grab the ID or the age or all these different aspects of particles from the particle source and put them into an array. Here I'm just going to do position. I can also do multiple frames if you want to do an animation, if they're animated over time. But I just need a single frame position, right? And now you can always look at this look at the data in this array to see if it's working by doing a print, array print node right here, and then just adding a note to the scene. So I can add a comment here. So here's my note. And so it's kind of cool. I can just plug this array into array print and this into the note like this. And then if I expand the note, I'll see like all these positions. These are the positions of the particle. So I know this is working. So I have an array of the particle positions here. Now what I need to do now, this is where it gets a little bit confusing even for me. We need to do what's called an array operator. An array operator, there's all kinds of operators in MODO. We probably need a whole series on operators. We have polygon operators and vertice operators and particle operators. Array operators. Basically what an operator will do is it'll take a bunch of information in, usually in an array, like a whole list. Think of an array as a list. So it'll take this list of values. You can manipulate them and then run it back into the array to get a new list of values and spit that out. Okay? So an operator is kind of like a little machine where you put a bunch of values into it. You can use some other nodes to change those values around or replace them or manipulate them or add to them or whatever. And then you can spit those new values out. And what we're going to do is we're going to take this array of positions and we're going to match them up with an array of color values in the same sequence. And that's going to give us our particle color in the same position as our particle position. Hopefully that's all making sense here. So I'm going to unhook this for now. We'll go back to this later. And so I'm going to add an array operator. And my input is going to be this array, like that. Now I need some other channels here. I'm going to add an element channel, and there's another element channel here, and an output channel, right? Well, the output channel is already added. So I'm going to add these two element channels. So I'm just sort of cutting back in here because I want to make sure I explain this correctly. So our array is a big list of things. Those lists of things are called elements. So we have an element out here. We can also go back into the element here where we're sort of remapping what those elements are. So in this case, the elements are all positions of the points. And we can see that by going down here to array print and going into the output, and we see all these elements here. But the elements have a certain data type, okay? So it could be vector, could be float, could be string, could be whatever. So you can actually, there's a node that'll tell you the sort of data type the element is. It's called, I believe it's called element type, array element type. So I can put that down here and I can plug in my array here, and I could just take a look at this and it'll tell me this element type is distance 3. So it is actually a different type than this position here in our UV texture probe. So we want the positions plugged into the UV texture probe, but it's looking for a different data type. And here we have what's called a distance 3 or vector 3. And we want to change that into a vector, right? So we're actually going to, we don't need this anymore. We're going to add a node called vector 3 to vector. I suppose it could be called distance 3 to vector as well, but vector 3 to vector, right? And you can see, like, you know, the little icons there, these 1, 2, 3 dots, 1, 2, 3 dots, that's what we want. So we just bring that in here, bring our element type into the vector 3. It's going to convert it to vector, which will allow us to plug it in to the UV texture node now, UV texture probe now. So now we've got positions going into our UV texture node, and this probe is going to match up colors to each of these positions, right? So that's what we want. We want to probe each of these positions, get the color at each of those positions, and then we're going to do more with that data. There's a couple more steps we have to do here. So we need to take the data out of our UV texture probe and put it back into our operator, right? So again, an operator brings in data, it does stuff to it, and then it spits it out, okay? So we've got the element out, we've done something to it, we've matched it up with colors in our texture probe, we need to put that back into the operator. So I'm going to take the element and the output here. I'm going to just unplug the output for now. I'm going to right click and say separate channel. Now I could keep them there and just plug these in, but it's a little easier to see like a node flow from left to right, right? So I'm going to put this over here, and I need to take the color and put it back into element. But again, we need to reverse our data step here and just, again, transform the formatting of the data into what this node wants. This array operator doesn't want these sort of vectors. It wants a vector 3, just sort of a different formatting of the data, as I understand it. So we're going to do vector to vector 3, which is just the opposite of what we did. So vector to vector 3, again, the icon helps you out there. And we're going to plug in the color. So we're taking that color data out, and then we're going to plug that into our element there. So now this array operator has changed that data. It's in the same order from positional data to color data. So I can also, again, look at my print array just to make sure I'm getting data here and say output into the array, and there I've got color data, okay? Looking good. So I think we can do something with this. And now we're going to move on to a node that comes with Emmy that is called array to particle, which will take all this array data and package it up as a particle node, okay? Which is what MODO's replicators and shaders want. It wants a particle node. It just doesn't want sort of raw array data. So I want an array to particle node. This comes with Emmy. So there's two Emmy nodes at play here. Particles to array and array to particle. I may actually need to grab this from the item list. They don't always, I don't think Steve's figured out how to get everything to show up in the schematic popover. So we want array to particles. It's right there. So we'll just add it to the item list there and then drag it into the schematic. And here we've got all our particle channels that we're used to, right? Position, ID, size, color. And so we're going to fill this array to particle node with positional data and color data. So we just plug in our color data that we got right there on our output. And then our positional data is just way back here, our original positional data, right? So we're just going to plug that in. So I'm just going to drag this. If you hold and just pause, it'll sort of zoom in on the node a little bit. So now we've got our positional data. And then I can plug this stuff into the replicator as the particle source. So this is our new particle source. It's not going to be our grid. It's going to be a particle source that has both the color and positional data packaged together. I'm going to plug this in here. Now, the only thing we're missing here is that the replicator can't read that. So that's sort of the color data, which is rather annoying. I think the replicator can be updated, but MODO's nodal shading offers us another solution. So if I go in here and I think that I'm done and I just press F8 to bring up a preview, I'll see that nothing's happening yet. And so I need to do one more step here. And what I can do here is do something called, use a node called shader inputs. Now, again, the shader tree is an integral part of MODO. It's awesome, and I think people who use it really prefer it over nodal shading. But MODO can do straight up nodal shading really well. It's all there. People just don't generally use it because at the end of the day, once you use both, it's pretty obvious the shader tree is better in the 90% case. This is one of the 10% cases where nodal shading is going to get the work done for us. So I'm going to add a new node here. I'm going to hit Tab, and I'm going to bring up, I'm going to type in shader, and I'm going to get particle sample. I'm going to drag that in. And so what this will do is it will, they're called shader inputs. If I come over here to shading and look at my node, I have a node here called shader inputs. That's this node right here, this particle sample node is a shader input node. And so a shader input node will take a look at the entire shading process on a per pixel basis, as I understand it, and it can grab information from that sort of in progress render. It can grab information about which pixels are reflective or which pixels are transparent or what the refractive index is. In this case, we're going to grab particle information from the renderer, and this particle information is held in this array. And so this particle information is available to the renderer, but the replicator has not seen it. But that's okay, we're going to actually color our particles using the shader input, right? So we've got my sphere here, right there, which is being used as the source for the replicators. The prototype, I'm going to just press M and call this sphere and create a mask for it in the shader tree right here. So here's my sphere mask. And so obviously if I change this, I change the colors, right? I'm going to add a constant to this. So processing constant, okay, constant's black, we can make it white, whatever. But what we're going to do is we're going to drag that constant color into the shader tree, and we're going to drive it procedurally from the info we get from the shader inputs. And the shader inputs are going to get this info from this node right here, which is put it into the scene. And we're going to make it visible to the shader tree via shader inputs because a replicator, through a limitation I would call it, cannot do that for us. So we're just going to drag our particle color into color right here, just like that. And when I hit F8 to bring up the preview, if I've done everything correctly, then each of these balls is going to be colored by the UV pixel color of the point that's underneath it. So let's take a look and see if I did it right. And boom, there we go. So each of the balls is picking up its color from the UV map underneath it. So actually, let me do it this way. Let me open up the shader preview window over here. Kind of go like this. And why don't I do something like just go over here to our UV map and change the offset to like 0.3 and 0.3. So I've changed the offset and it picked up the colors, right? I can change the wrapping and it's going to pick up the colors, right? So yeah, that's a simple way, or not a simple way, that's a rather complex way of assigning UV sampled colors from the point that the replicator point source is to the replica. Now, we need an easier way to do this. And so I think we'll do a part 2 of this. And so this is sort of the basic setup. We're going to do a part 2 video where I do a more complicated setup using DEX as the particle source, the DEX particle system by Frederick, which is the particle packing system kit from MODO, which again, everybody should buy. It's like super awesome. And then I think I'll package it up into an assembly that I can save so I don't have to like remember how to do all this stuff every time I need to do this effect.
Yum, yum!